What specific problem does the proposed method, Retrieval-augmented generation systems, RAG, aim to solve according to the paper?
The proposed method, Retrieval-augmented generation systems, RAG, aims to solve the problem of knowledge conflicts between parametric and contextual information in language models. RAG combines a generative language model with a non-parametric data store to update a system's world knowledge without the need for costly retraining. It addresses the issue of outdated or incorrect parametric knowledge by allowing language models to rely on factual information from retrieved documents, thus enabling them to update their knowledge according to real-world contexts. RAG systems excel in solving knowledge-intensive tasks, modeling long-tail knowledge, and providing attribution of generated text to identified sources. The method is particularly useful in scenarios where pre-training data may become obsolete, downstream tasks require different factual knowledge, or large-scale text corpora contain untrustworthy information. By leveraging RAG, language models can enhance their performance and adapt to new information without the limitations of purely parametric models.
How does the proposed method or algorithm work, and can you illustrate it step by step based on the details provided in the paper?
The proposed method in the paper aims to study knowledge updating behaviors in language models, LLMs, under realistic knowledge conflicts, specifically focusing on cases where there is a conflict between parametric and contextual knowledge. The method involves a three-stage experimental framework. 1. Stage 1. Closed book answer gathering. In this stage, the model is probed for its parametric knowledge by running it on a dataset without context. The answers obtained are saved for further analysis. 2. Stage 2. Filtering out no-conflict examples. A knowledge conflict dataset is created by filtering the closed book answers. This involves removing correct answers and answers that do not contradict the context using a natural language inference (NLI) model. 3. Stage 3. Open book QA under knowledge conflict. The model is then tested on the subset of the dataset created in Stage 2, but this time in an open book fashion, meaning with context. The answers are categorized into 3 sets: correct update, knowledge update succeeded, retain parametric, model retained its parametric answer, and incorrect update, model changed the answer but failed to answer correctly. The method involves running experiments on various open book QA datasets using different LLM models like Llama 2-7b, Mistral 7b, and Mixtral 8x7b. The evaluation metric used is BERT matching (BEM) instead of exact match (M) for more precise evaluation. The results of the experiments show that when presented with factual real-world documents, the models tend to update their knowledge correctly in most cases, with a very small percentage retaining their parametric answers. The study also uncovers a parametric bias, where the presence of the incorrect parametric answer in the context negatively influences the model's reading ability, leading to knowledge update failures. Intervention experiments involving masking the parametric answer and adding it to the context further confirm the existence of this bias.
What are the theoretical or practical benefits of using the RAG method compared to existing alternatives, as discussed in the paper?
The theoretical and practical benefits of using the Retrieval-augmented generation RAG method compared to existing alternatives, as discussed in the paper, include the ability of RAG systems to update a model's world knowledge without the need for costly retraining. RAG systems enable models to update their knowledge based on retrieved documents, allowing for flexibility in incorporating new information without starting from scratch. This is crucial in scenarios where factual information may become obsolete over time, as seen in the lengthy pre-training process of large language models. Additionally, RAG systems excel in solving knowledge-intensive tasks and modeling long-tail knowledge, providing attribution of generated text to identified sources. This attribution feature enhances transparency and credibility in the generated content. Moreover, RAG systems mitigate the risk of using untrustworthy information from large-scale text corpora by enabling the incorporation of domain-specific and reliable information from retrieved documents. Overall, the RAG method offers a more dynamic and adaptable approach to updating a model's knowledge base, ensuring relevance and accuracy in various applications.
How is the validation process of the RAG method described in the paper?
The validation process of the RAG method in the paper involves studying knowledge updating behaviors in LLMs under realistic knowledge conflicts. The study focuses on how often LLMs update their parametric knowledge when presented with factual contexts. The experimental design includes 3 stages: closed book answer gathering, filtering out no conflict examples, and open book QA under knowledge conflict. In the open book QA stage, the models are queried with context and the answers are categorized into correct update, retain parametric, and incorrect update subsets. The study uses a novel framework that mirrors real-world RAG application and relies on open book QA datasets for perfect retrieval of ground truth answers. The validation process also includes investigating the remaining failure cases where knowledge updates did not occur and conducting intervention experiments to understand and potentially mitigate errors, such as the parametric bias phenomenon. The results of the intervention experiments provide evidence for the existence of the parametric bias, showing that the appearance of the parametric answer in the context increases the likelihood of the model retaining its parametric answer.
What were the main results achieved with the RAG method according to the paper?
The main results achieved with the RAG method, according to the paper, include the successful updating of a model's knowledge when presented with factual contexts, the identification of a parametric bias where models may retain incorrect parametric answers in the presence of conflicting context, and the demonstration that the appearance of the parametric answer in the context document increases the likelihood of a knowledge update failure. The study found that in realistic knowledge conflicts, language models tend to update their knowledge when provided with factual contextual information, with a very small number of cases where models retain their parametric answers. Additionally, intervention experiments showed that masking the incorrect parametric answer reduced the probability of the model retaining it, and artificially adding the parametric answer to the context increased the likelihood of the model retaining it, providing evidence for the existence of the parametric bias. The paper also highlighted the importance of context quality for successful knowledge updates and emphasized the potential implications of the parametric bias on the reliability of RAG systems.
What are the limitations or drawbacks of the RAG method discussed in the paper?
The limitations or drawbacks of the RAG method discussed in the paper include the potential for knowledge conflicts to arise when the model's parametric knowledge contradicts real factual documents, leading to knowledge update failures. Another drawback is the existence of a parametric bias, where the model may retain its incorrect parametric answer if it appears in the retrieved document, negatively affecting the model's reading comprehension abilities. Additionally, the paper highlights that while RAG systems have high knowledge update success rates, the open book performance of LLMs is still influenced by their parametric factual knowledge, indicating a problematic interaction between parametric and contextual knowledge. The study also suggests that parametric bias could become a larger issue in RAG systems with evolving knowledge and complex, realistic documents. The paper acknowledges that while the research uncovers these problems and provides a way to evaluate their impact, finding solutions to mitigate these biases is left for future work.